So our two main types of volcanoes are differentiated because there's really two main types of lava or magma, depending upon where we're talking about. One is mafic lava. Mafic, as you learned in notes, has more iron and magnesium, and therefore more dark silicate minerals. And felsic has more light silicate minerals and has less iron and magnesium. So mafic exists in nature at a higher temperature. It exists at about 1200 degrees Celsius. And in part that temperature, and in part just the nature of mafic lava, you can see that as I pour some, by the way, I'm using ketchup to simulate it. They've actually done a study and found that the viscosity of mafic lava is quite similar to ketchup. And as you can see, although it's much more viscous than, say, water, as I squirted it out of my ketchup container, it's spreading out. The other kind of lava is called felsic. And felsic has a viscosity at its natural temperature at about 800 degrees Celsius, very similar to peanut butter. And so peanut butter, as you can see, is much more difficult to get off my spoon. I probably could squirt it through a bottle, though, like I did ketchup. But you can see that this pretty much sits in the way that it came out. If I gave it enough time, eventually peanut butter would settle out and kind of do what the ketchup did. But the peanut butter, which is standing in for our felsic lava, it has a much higher viscosity. And we can see that that viscosity then corresponds, let me flatten that out, corresponds to how the lava piles up to make a landform. If I look at this from the side, you can see one creates a much more domed shape, and the other one has a much steeper shape. Now, if you imagine letting these sit so long that they hardened, what you might find is that this one eventually might topple over. Whereas this one, because it spreads out so much, I can create a really stable base and really make it quite tall.